Alright, now to do this question, you must first of all understand that this what you're going to use is a binomial theorem expansion, and what we have here is a trinomial expression, right? Because there are three terms here, right? As you can see, 1, 2, 3. So what is the first thing that we need to do would be to convert this into a binomial. Alright, so we're going to see this as though it's the two terms inside. So the first term we have it be 1, and we'll move the positive term to the front so we won't have an issue with the signs. So let this be the second term, and the whole thing to the power 6. So basically we're not doing much, but we're just rearranging, and we see this as our first term and see this as our second term, and now what we have here will be a binomial theorem expansion. So the next thing is to understand that what we have here is something going to be quite tedious to do, and that is we're going to have a binomial within the binomial. What I'm trying to tell you is that, well, look at this and think about it this way. All right, if you were to expand this, you're going to have 1, and you're going to have 6c1 and then multiply by this second term, okay, and of course the next one will be 6c2, and we're going to have x cubed minus 2x squared, okay, and of course we're going to have 6c3 x cubed minus 2x cubed, and so on and so forth. Now, but of course we must pay attention and focus on our question. And what the question wants us to do is to find the x to the power 7 term, and you obviously should be able to tell that, well, this is just a constant, there's no x at all. This expansion, if you go work it out, this term, there isn't any x7 anyway, so to some extent this is useless. So this is useless, this is useless. All right, take a look at this again. This one, right, that's the square to it. So the highest power you ever achieve will be x to the power 6, and it happens when you have x cubed square. So it looks like you're not going to get x power 7 from this expansion as well. So therefore this is pretty useless for us as well. So you see how challenging it can be. So, and that is for you to go figure out which term will actually give you x power 7. So if you look at this, there are a total of 7 terms, okay, because it's power 6, and therefore you have 7 terms in total if you go expand it out. Now this is the one that we're going to give you, that's going to give you a 7 inside. Now why do I say that? Well, because if you look at the highest power, which is x cubed, then the highest power will be x cubed, so that gives you x9. So highest is x9. That means to say that there's a chance that x7 may be popping up somewhere in between. Okay, so meaning to say, what we need to do is, of course, we need to consider this term, okay, as part of our answer. And therefore, let's think about what is the next one, right? 6c4 x cubed minus 2x, and this is 4. And again, if you look at this, the highest power will give you 12. So how are you going to know whether is this going to give you your power 7 or not? The point is that we won't know. I mean, you can go figure out, but okay, we have to assume that there is x power 7 inside. Okay, so anyway, this is at 3, 4, and then we have 2 more, right? So that will be 6c5 x cubed minus 2x power 5, and the last one, which is 66, which is 1 x cubed minus 2x and power 6. So our focus will be only on this 4 expansion, and let us pay attention to this 4 now. 6c3 x cubed minus 2x whole thing cubed. Now, is there an x7 inside? Well, how do we find out? Again, like I told you, this was a binomial itself, right? So it's a cubic binomial. So cubic binomial is not that bad for us to figure out, because you know, it's just 4 terms, right? So 6c3 is 20, so let's work it out, 20. And inside here, what we're going to have is we're going to have many terms, right? We're going to have like x cubed and then negative 2x. So we're going to have 3, 0. Now, the combination of 3, 0 is not going to give you power 7, because this is going to be power 9, right? So 3, 0 isn't helpful for us. How about 2, 1? All right, now this will give us 6, and this will give us 1. So 6 and 1 will give us 7. So that sounds like correct. So this is 3c1, okay, and x cubed square minus 2x power 1. Okay, so let's work this out, and we end up having negative 6 times 2, negative 120 x power 7. Right, so this is from here. So let me highlight for you. Okay, so this is from here. Okay, so we got 1, and now we have 3 more brackets to figure out. So let's go on to the next one. Right, next one will be 6c4 x cubed minus 2x, and this is power 4. And let's think about okay, 6c4 is 15. Okay, to be honest, we may not want to figure this out first, because for all you know, we don't even know whether is there any x power 7 term inside. So let's try to find out. Alright, so this is x cubed, and this is minus 2x. Okay, so again it's 4. So 4, 0 is not going to give us the power 7, isn't it? Because it's going to be 12 and 0. So alright, you can forget about the 4, 0. And how about 3, 1? 3, 1 again, this will be 9, 9 and 1 gives us 10, so it doesn't look like it. 2, 2. 2, 2 will be 6, 2. 6 and 2 give us 8. So the power 8, nah, that's not what we want. And how about this 1, 3? 1, 3, well, 3, 3, this is 6. And you start to realize that, hey, this is not going anywhere, because the next one will be 0, 4. And you know that it's just going to get 4, power 4. So you probably realize that you pass the chance of having power 7. So in other words, this term, this expansion is not going to give us any power 7. So this is not going to be helpful for us. Okay. Okay. So now we take a look at our next term, which is this one, right? The one with 6c5. So let's try. Okay. So 6c5. X cubed minus 2x whole thing to the power 5, and 6c5 is just 5. Okay, and of course we know that we're going to have x cubed and a negative 2x, and power 5, right? So power 5, let's think. All right, now 5, 0 is not going to make the cut, right? We're not going to get 7 from here. How about 4, 1? Well, 4, 1 neither. Okay, so of course you can go ahead and try again, and probably you will realize that you get 1, 4. Okay, 1 here, 4 here. This will give us 7, 9, 7. So this will be a 5c4, right? So the term is 5c4, and if you work this out, 5c4 is 5. So what we have here is 5, and then another 5. And 2 to the power of 4 gives us 16. So this is 16x7. Okay, and after we work this out, this value turns out to be 480 x7. Okay, good. So we got our target, right, which is the x7. So this x7 term, let's color code it again. Okay, it comes from this term. Okay, this term. So and we go on, right? We go on to the last bracket, and we try the last term here, and we try to see if this last term is able to give us an x power 7 or not. Sorry, this should be power 6. Okay, so well, it turns out that this is actually just another binomial, so it's actually not that bad, not that difficult as well. So we have this. So let's think, what combinations can we have, right? 6, 0. Nah, that doesn't work. So probably you can jump a little bit, right? Not test every single combination. So this 3, 3 is out as well. So we can try 2, 4. 2, 4, this is 6, this is 4, that gives you 10. Nah, that's way too far. 1, 5. 1, 5 gives you 8. It's pretty obvious, right? So the next one is 0, 6. And 0, 6 doesn't give you 7, and you realize they actually passed 7 as well. So this is not going to give us power 7 anyway. So turns out that even though we have so many terms in this expansion, that we actually don't have to pay attention to that many of them, right? So straight away we cross out this fella, this fella, this fella. We can cross it out because we know immediately that this is not going to give us any x power 7. And similarly, after we analyze it a little bit more, we also realize that this is off, and turns out we only have 2 terms that are x that has got x power 7. So what we have, so we can write therefore the x power 7 term will be simply the 580 minus 120, that gives you 360 x power 7. So this should be the correct answer for the of course when they ask you for coefficient, and therefore the coefficient will be just, okay, the answer itself will be just 360. Okay, so there you go. This is a pretty challenging binomial expansion question, but well, it's kind of special. Okay,